let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. I think all of you are okay. I am PS Chatterjee, and today, we'll explore a faster and more convenient way to create concrete mixes on site, volumetric measurement. The amazing inside story of concrete. Hey everyone, let's take a trip inside the world of concrete. This might seem like a simple material, but there's a whole lot going on beneath the surface. Take a look at this diagram. The secret ingredients: stone chips and sand. These are our rocky reinforcements, like the chunky bits in a cookie. They come in different sizes, with the bigger rocks, coarse aggregate, and the finer sand, fine aggregate, working together to create a strong and stable structure. Cement, this is the magic glue that holds everything together. When mixed with water, a chemical exothermic reaction happens, making the cement harden and bind the rocks and sand into a solid mass. Water, it might seem simple, but water is essential for the cement's hardening process. Just like you need water to activate fast-acting baking powder, concrete needs water to activate the setting of the cement. So, what happens next? Once these ingredients are mixed together, they form a thick, pourable mixture. This allows us to mold the concrete into different shapes, like building blocks or even complex structures. As the water reacts with the cement, the mixture hardens, and the stone chips and sand get locked in place, creating the strong and durable concrete we rely on for so many things. In our previous video on concrete mix proportioning, we explored the concepts of nominal mix design using IS 456 standards. The key takeaway was that these mixes specify ingredient ratios by mass, in kilograms. Want to see a practical demonstration of volumetric measurement in Excel spreadsheet? Subscribe for upcoming episodes. Dry volume versus wet volume of concrete. In this slide we are going to know about dry volume and wet volume of concrete. To determine the amount of dry concrete mix we need, to start with the final wet volume required for the project. Wet volume is the amount of concrete after adding water in it. Further, continuation of dry volume vs. wet volume of concrete. Volume increase, the 1.54 factor comes into play because it accounts for this difference in volume. It essentially tells you how much extra dry mix you need to account for the air spaces that will be filled with water. Calculation for volume of dry mix. In this slide we are going to know how to calculate dry volume of concrete. Say we need 5 meter cube wet volume of concrete. We have to adopt a conversion factor equals to 1.54, and we have to multiply this with wet volume of concrete. So required dry volume of mix equals to 5 meter cube into 1.54 equals to 7.7 meter cube. Calculation for transportation loss. Transportation loss can occur, and we need to consider it separately, while specific considerations are necessary. Here are some general buffer ranges used in construction based on anticipated transportation loss considerations for spot mixing. Since spot mixing eliminates the transportation factor, here are some ways to address potential loss during the mixing process itself. Number 1. Proper mixing techniques. Proper mixing techniques ensure thorough mixing of all dry ingredients and water to minimize material loss due to incomplete incorporation. Number 2. Careful handling. Careful handling minimize spillage during mixing and pouring to avoid unnecessary loss. Number 3. Batch size adjustment. For critical pours, consider mixing slightly larger batches than the exact volume needed to account for potential loss during spot mixing. Title of this slide: Buffer percentage. Even with precautions mentioned in the last slide, a small buffer percentage might still be considered for unforeseen circumstances. This buffer could be low risk, medium risk, and high risk. In this table you are watching that buffer percentage on the basis of low risk, medium risk, and high risk. Number 1, low risk. When we have experienced crew, good weather, this situation is known as low risk, and buffer percentage for this situation is 1 to 2%. Number 2, medium risk. When we have moderate experienced crew, average weather, this situation is known as medium risk, and buffer percentage for this situation is 2 to 3%. Number 3, high risk. When we have inexperienced crew, hot weather, this situation is known as high risk, and buffer percentage for this situation is 3 to 4%. Title of this slide: How to calculate volume of concrete ingredients. Average of density of the concrete ingredients, kg per meter cube. Coarse aggregates, 1,200 to 1,750 kg per meter cube. Fine aggregates, 2,650 to 2,800 kg per meter cube. Cement, 3,150 kg per meter cube. Dry concrete, 2,300 kg per meter cube. Say we are going prepare 5 cubic meters of concrete, grade M15. As we calculated in our slide number 7, the total quantity of dry aggregates equals 7.7 meter cube. Total dry weight of concrete equal to 7.7 into 2,300 equal to 17,710 kilograms. We also know that the ratio of concrete ingredients equal to 1:2:4. Total quantity of dry aggregates equals to 7.7 meter cube. Total dry weight of concrete equals to 7.7 into 2,300 equals to 17,710 kilograms. We know ratio of concrete mix equals to 1:2:4, where cement equals to 1, fine aggregates equals to 2 and coarse aggregates equals to 4. Weight of cement equals to 17,710 into 1/7 equals to 2,530 kilograms. Volume of cement equals to 2,530 by 3,150 equals to 0.803 cubic meters. Cement per bag equals to 50 kilograms. Required numbers of cement bags. 2,530 by 50 equals to 51 bags. Weight fine aggregates equals to 17,710 into 2/7 equals to 5,060 kilograms. Volume fine aggregates equals to 5,060 by 1,200 equals to 4.22 cubic meters. Weight of coarse aggregates equals to 17,710 into 4/7 equals to 10,120 kilograms. Volume of coarse aggregates equals to 10,120 by 1,200 equals to 8.433 cubic meters. Quantity of water as per Table 9. Water per 50 kilograms of cement, maximum equals to 32. Volume of water, maximum, equals to 51 into 32 equals to 1,632 liter. Final volume of the materials in cubic meter. Coarse aggregates, 8.433 cubic meters. Fine aggregate, 4.220 cubic meters. Cement, 0.803 cubic meters, or 51 bags. Water, 1.632 cubic meters. Thanks for joining me today. Did you learn something new about concrete mix on spot? In my next video, we'll dive into concrete mix on spot using Excel. Don't miss it. Hit that like button, share this video with anyone who might find it useful, and subscribe for more concrete tips and tricks.